I am so excited to talk to you about this because this has been something that has been a bugbear of mine. And if you're a longtime listener of the show, you remember I talked about trying to work on a project relating to figuring out how much power these AI systems are using. And unfortunately, I hit the same roadblock that a lot of other people trying to do that did, which is that none of these companies have been very forthcoming about the actual data about their power and water use. We've had to go off of sort of strange sideways estimates. I've had a power meter hooked up to my computer for almost a year at this point too, and checking like the inference power use of local models, but still no one could really tell you how much power these systems use at scale. And a data center environment is a completely different thing to any kind of home server. So this is really crucial data. Now, it's coming straight from Google, which of course has a vested interest in maintaining a good public perception and seeming like they're doing good things, obviously. I think this is actually a pretty good thing, though, and I'll tell you why as we dig into it. First, I'll start by showing you the video that they released, which I think is edited in a way that's a little bit confusing, but stick with me because we're going to break all of this down. This is the video straight from Google called Calculating Our AI Energy Consumption.
Specifically, what we're looking at is today what the environmental impact of an AI query is, and also what the improvement over the last year has been.
We've had, a 20 to even more year history of publishing data in this space, showing what our, power usage effectiveness ratio is for data centers. We want to drive that ratio as close to 1 as possible. People have understandably, concerns about, is this going to be using a lot of energy? Is it hurting the planet in various ways through carbon emissions?
What we see is the most comprehensive approach to measuring the energy consumption for AI across the full stack. So it's not just looking at the models, it's not just looking at the hardware, it's also looking at the infrastructure and how everything gets orchestrated.
There have been other efforts that look at the inference cost of various AI models. In some cases, the methodology that was used there is not really that close to what a production serving system uses. So the numbers usually end up being much higher because they don't incorporate things like, say, speculative decoding or large batching of requests into making the overall system much more efficient.
We're actually measuring the energy consumption of these AI models on Google's data centers. And what that means is that we're not just measuring the power from the chips, we're actually looking at the utilized TPUs and GPUs in Google's system.
People were wondering, like, if I do a Gemini query, is that equivalent to driving a car 1,000 miles? And the answer is absolutely not. Like, the data we gathered shows the carbon emissions are actually quite small.
The energy consumption and carbon emissions and water consumption were actually a lot lower than what we've been seeing in some of the public estimates.
AI models are scaling so quickly. There needs to be good metrics today to make sure that we're building these models in the most efficient way that we can.
So if, like me, you're thinking that, of course, Google has an incentive to make it seem like they are not using that much power or water, I think that, again, is a healthy degree of skepticism to have towards a massive corporation, right? So let's dig into their report and let's look at some numbers here. So I'm reading right now from MIT Technology Review to start us off. They said, Google has just released a technical report detailing how much energy its Gemini apps use for each query. In total, the median prompt, one that falls in the middle range of energy demand, consumes 0.24 watt-hours of electricity, which is the equivalent of running a standard microwave for about 1 second. The company also provided average estimates for the water consumption and carbon emissions associated with a text prompt to Gemini. So a caveat right out of the gate is that we are talking only about text prompts. We're not talking about images or videos. We know those use more power. Just talking about text prompts, just talking about Google Gemini too. We don't know about OpenAI, XAI, and all the others. So with that out of the way, they looked at not only, and they mentioned this in the video, not only like the theoretical maximum utilization of all the chips they have, which is kind of how we've been doing the estimates now. They looked at the energy demand that's actually being used by the chips. They also looked at all of the supporting hardware. So I'll hop over here on screen to Google's page about this. They took into account the full system dynamic power. So not just the energy and water used by the primary AI model during active computation, but also the actual achieved chip utilization at production scale, which can be lower than the theoretical maximum. They also took into account idle machines. They have to have a bunch of systems that are offline, not offline, but just sitting in the wings, waiting and ready to go so that their system can be reliable as demand increases and decreases. So they took into account the energy use, water use, power use, all of that of these idle machines. They also didn't base it just off of GPUs. They looked at the CPU and RAM usage as well, because AI model execution doesn't happen only on the GPU or Google's TPUs. The CPU and RAM also play a crucial role and use energy. And again, they also looked at the data center overhead, all of the stuff to support it, cooling systems, power distribution. That other overhead is wrapped up in a metric called power usage effectiveness. And of course, they also looked at water consumption. And again, that meme that has been persistent, and I still see it to this day, and people bandy it about as though it's true that a single ChatGPT query dumps out an entire cup of water. What Google has found was that a single Gemini text prompt, the average text prompt, uses approximately 5 drops of water. I've jumped back over to MIT Technology Review. They said that Google's custom TPUs, their proprietary equivalent of GPUs, account for just 58% of the total electricity demand. Another large portion of the energy is used by the equipment needed to support that hardware. So the CPU and memory account for another 25%. The backup equipment ends up taking about 10% of the total. That's those idle machines. And then the final 8% is overhead with the data center. So that's how it kind of breaks down. Later in the article, they talk about how Google has made a lot of purchases. They've signed agreements to buy over 22 gigawatts of power from renewable sources, including solar, wind, geothermal, and advanced nuclear projects. And because of those, Google's emissions per unit of electricity on paper are on average 1/3 of those compared to the average grid use. So Google does start out with an advantage here on the power usage front in terms of they are investing in clean energy, unlike where we've heard about other places spinning up like fossil fuel plants to power AI, which is obviously not good. So bear that in mind too. Google estimates that each prompt consumes 0.26 milliliters of water, or about 5 drops. They go on with a quote here saying, people are using AI tools for all kinds of things, and they shouldn't have major concerns about the energy usage or water usage of Gemini models, because in our actual measurements, what we were able to show was that it's actually equivalent to things that you do without even thinking about it on a daily basis, like watching a few seconds of TV or consuming 5 drops of water or using the microwave. And I think that's really sort of the crucial thing that has bugged me in most of the discourse around AI power use. Everything you do that is electrical uses power, and you don't tend to think about it unless you're trying to like make some kind of point. So as an example, I've had this power meter plugged into my computer for like over a year, and I just check on it periodically while I do various tasks to see how many watts my computer is using instantaneously doing different things. Running Fortnite, while I have Fortnite running, uses more power than when I generate an image on my machine locally, for instance. So like all of those simplistic things about how much power and water they use never passed the smell test for me. This seems to be a bit more realistic. And again, I really want to see the numbers from other companies because again, Google's got that advantage with their investment in cleaner energy and things like that. Their breakdown goes into more of the things they do to help optimize their energy use and things like that. So if you want to read deeper into it, you can. They also put out a research paper. It's only 10 pages long. I have it printed out that I'm going to go read this evening because again, this came out just a few hours before the show. So I haven't had time to dig that deeply. But as I did skim through this research paper a bit, and specifically I was looking for the parts about water because I wanted to see, Google has this thing where they've pledged to return 120% of the water they use. And I wanted to see if they were doing something sneaky, similar to, it's not really sneaky, but similar to the electricity where they're buying a lot of renewables to offset the average grid dirtiness wherever they're operating, right? I wanted to see if they were doing that with water because of their water commitment. But actually in the paper, they say that they only count their consumption. So I'm feeling more inclined to believe what they've put out here. I feel like this data isn't super manipulated. I feel like this is actually good data. But again, I am not like an authoritative source on that. Other people who are much smarter and much more like narrow focused on this stuff, I hope will come out with more detailed analyses. But from my own sort of reading through it, it does pass the smell test as far as like not seeming like something they did just for public relations. It seems like there's good information in here. And it also makes an intuitive kind of sense. Not that that is something you should really go on, when it comes to science and data, but like it wouldn't make sense if a single GPT query or Gemini query took a whole glass of water. That just would not be feasible at scale. And 5 drops for an individual person doesn't sound like a lot, but remember how many queries are they processing, right? So these things still do add up. And then even in all of this, in these power discussions, data centers make up a single-digit percentage of energy usage. I wanted to have it ready to quote, but I don't. But I think it's less than 8%. It's somewhere around there. And it's projected to go up, but a lot of that is speculation on the rate of change, the second order derivative or whatever. So I think this is great. in terms of giving us more data points, more realistic data points about how much power these systems use, because it's very important that we don't just destroy the climate. Obviously, I'm very passionate about that. But I have seen the segment timer tick down to 0. So I'm going to let this one go. I'm going to link everything in the show notes in the description for you. You should go check it out. But AI doesn't seem to be the energy-sucking monster that everyone wants to paint it as. However, there are things like the scaling race and cramming AI calls into things that don't need it, like every single Google search or your pizza app generating a picture of your pizza before you order it. So this discussion around power usage really needs to be more nuanced. Ooh, I knew I said I was going to end it. But okay, here's my last thought. Whenever you choose to do something, you have to understand the cost associated with it and if you think that is worth it. So therefore, if an AI is just going to generate a pizza for you that you didn't ask for because you're ordering a pizza, that is a complete waste of power. You didn't want it to do that. But if you are using an AI to help you do something, it's doing that thing for you and using power. That's pretty much the same as playing a video game like Fortnite or rendering an image in Blender or doing anything that uses power, right? So it's all about that sort of trade-off. And also maybe I'm in a bubble where I just see a lot of these memes that are like AI is going to burn us all down. Anyway, I'm going to cut myself off before I just start ranting. We're going to move into our next segment right after this quick break, and we're talking about hierarchical learning models, a different kind of architecture that's really cool and extremely good at reasoning through tough problems. Stay right here.